All right, so we're doing y the first rule for 11.5. All right, so what I want to think is I want to start with the left-hand side. So I'm going to talk about log base b of x times y. And I'm going to think to myself, okay, there's probably an answer to log base b of x, right? So I'm going to think, okay, log base b of x is something. I've used up lots of letters. So I'm going to just pick a different letter that I don't have, like an n. Okay? So really what this means is that b to the n is x, right? You guys cool with that? All right, now I'm going to call something else, like log base b of y. I'm going to call that something else. I'll call it m. That's me saying that b to the m is y, right? You guys see that? Cool. Okay, so now I'm thinking about this guy, right? So I can think about this in two different ways. The first way is I could just stick these two guys in for x and y there, right? So I've got log base b of, actually maybe let me just write this. So this is log base b of b to the n times b to the m. Right? Okay. Now one of my exponent rules lets me do what with the powers?
Add them?
Yeah, I can add the powers. So this is log base b of b to the n plus m power, which gives me, what's the answer to the question, what power do I raise b to get b to the n plus m?
N plus m.
N plus m. Or I could think about these two functions undoing one another, right? Either way, I get n plus m here. Okay, but then I should ask myself, wait, what was n? That wasn't in my original problem. My original problem only had b's, x's, and y's in it, right? So what was n's relationship to b, x, and y?
Log bx.
Yeah, it was log b of x, right? So I'm taking this thing and I'm putting it in for n. You see that? So I get log base b of x. That's n. And this guy makes that guy. Those are the same thing. Then, what am I adding to that? I'm adding
Log by.
m, which is log by. Okay, see that? So this right here, that's my rule, right? So why did my rule happen? Well, really there wasn't anything except that exponent thing in there, right? Yeah, so really this rule about logarithms, this first rule, is really that same thing about adding exponents. You guys see that? So when we're kind of putting this in our head, right, we put it in next to the ones, add exponents, subtract exponents, and multiply the powers, because that's what they're doing. You guys see that? You want to see the third one? Okay, so on y, the third one, we're doing log base b of x to a power is a power times log base b of x. Right? Wait, we're trying to show this. Let's start with just the left-hand side. See if we can get the right-hand side. Okay, so what was my trick last time? You guys recognize what the kind of weird trick was last time?
Setting x to be something else.
Yeah, I sort of replaced x with something else, right? I replaced x with some power of b. So let me do that same thing. Let me say, okay, this is log base b of b to some power to the b. This is me thinking, right? N is log base b of x. That's that same substitution I made over there for x. That's why I'm not rewriting it. You guys cool with this? Okay, now what do I do with the powers? Multiply them, right? So I get log base b of b to the n times p. What do I get out of that?
NP.
Right? N times p. But what's n?
Log bx.
Yes. So I get p times log base b of x. So now, first thing and last thing, that was that rule. You guys see that? So that last rule was really just the thing about multiplication of powers. That said, I do advise you to stick these actually. I do advise you to stick these actually in your mind, right? Don't just assume that you can get them out of the multiplication of powers or addition of powers or whatever, because they're not super easy, right? This isn't something I expect for you to be able to actually reproduce. Cool? At this level, I'm not expecting you to bring this back out later, but I do expect you to know the rules. Cool?